My name is Albert Mathis, co-captain of FTC Team 772, the Golden Dragons, and this is our robot for the 2025-2026 season, Batsune Miku. This year, for our games challenge, many teams decide to either try and shoot fast or try and sort balls when they shoot from their robot. We decided to do both, and this is how we did it. Our story first begins with our Spindexer. So when the season first started, we wanted to have a way to intake 3 balls and sort them before we shoot. This is so that we could score our pattern. The way we decided to do this was by creating a revolving mechanism that could hold 3 of the artifacts at a time and then spin them around in a circle. This allowed us to choose which artifact we would queue up to shoot. To detect which balls we have in our Spindexer, we use a camera running a computer vision pipeline. This pipeline will look at the ball and detect its color, and then it will store it in a system where it will then revolve around in circles to see which ball is the best to shoot at the moment. Once it's ready, it gets shot. But how do we do this? Well, this comes down to one of our robot's most unique designs, our indexing system. On our intake, we have 2 sets of rollers. Our first initial set of rollers to bring the balls into the robot, and a second set of rollers. This second set, we decided to put on a pivot so that whenever it's time to shoot, we can harness the ability of our robot's shooter mechanism, our intake mechanism, and then use it to shoot the ball out and push it into the turret. The reason we did this is to save space, but it also adds a lot of speed into our robot. Since we're able to use this intake roller as a small flywheel, we are then able to mesh this spinning speed with the spinning of the Spindexer to then push the ball upwards into the turret. This allows for really quick shooting that is oftentimes under half a second. Once the ball gets out of the Spindexer and into our shooter, we then use a turreting design to move our robot to whatever angle without having to turn the entire base. This allows us to quickly shoot without having to align our robot with the goal. So, how do we do this? Well, originally we used our odometry and a gyroscope to get the position of the goal relative to our robot. But this would drift. This idea of the robot on the field would move a lot because of the vibrations coming from this flywheel. So what we did to combat this was that we added a second camera, a limelight, onto our turret that would automatically look at the April tags on the field and then determine where the robot is in relation to that April tag. This allows us to fuse the sensor readings from both the limelight and the odometry to get an extremely accurate idea of where our robot is on the field. This limelight is also used to detect the pattern of the obelisk so that we can then shoot in the pattern during the autonomous period. With all this information, our turret is then able to turn and aim itself and adjust this hood and the flywheel velocity such that we can make the perfect shot from anywhere on the field at any point in time. So, now that we've done with this, our robot can also park. But since our robot is so big to hold all 3 balls, we decided that we need to take a little bit of a unique approach to parking such that we can save space and allow room for our other team member to park. So what we added was a small lever under our robot that is powered by 2 servos. This lever will push the robot up at the very end of the match so that we can fit inside of our parking rectangle and still provide enough space for a partner to come in and park with us. This concept allows us to fit in 2 robots and get even more points from our parking. Now, throughout Auto, the autonomous period, we decided to develop our own pathing library, Dragon Path, so that we can move our robot. Why not just use a custom off-the-shelf pathing library? Well, a lot of those libraries are very complex and very difficult to use, and oftentimes they can have a lot of inaccuracies. So what we decided to do was we wanted to make it as simple as possible. We made a very short pathing library that can quickly move our robots across the field and hold position there. This allows us to score really high scoring autos throughout our matches and makes it really easy to troubleshoot as well as pass down to our team. Finally, as you can see, none of this robot was built in a vacuum. We obviously have many team members who are working on this and iterating, bouncing off each other's ideas all the time. And we also seek help from people from all around the world. We've looked for people all the way from Romania to Washington State. So we really have a wide variety of help just influencing this design so we can make it as competitive as possible.